We were talking about algebraic and geometric proofs, and we're still thinking about what statements can we make. In this case, we're looking at pictures that are given and what statements can we make from there. And so the first one that we have is we have a line segment with G's between F and H. So we could say the segment FG plus GH is equal to the whole thing, which would be FH. And the reason that we can say that is segment addition. Postulate. All right, next example we have, this says it's a bisector. So if this is a bisector, what that means is it cuts it in half. And so if it's a bisector, we can say, oh, these two sides are going to be equal. So I put that congruent on there. And we can say M is the midpoint of line segment AB. So M is the midpoint of line segment AB. And that one will be definition of segment bisector. Next we have midpoint, and so this is specifically telling us that it is the midpoint. And so if I put 3 marks over here, I can put 3 marks over here. And what that says is line segment RA is congruent to line segment AM. And that is going to be definition of congruent segments. Definition of midpoint. Next we have line segment JK is congruent to line segment LM. And so I'm going to put 4 marks on this one. So if I put 4 congruent marks on this one, I need to put 4 congruent marks on this one as well. And in this case, we can say JK is equal to LM, and we can say that by definition of congruent segment. And we got a couple more examples. So here, that's the perpendicular sign. So it says line segment AB is perpendicular to line segment BC. And in this case, we can say if it's perpendicular, you want to make our mark on the drawing, put that box in the corner. So then we can say angle ABC is a right angle. And the reason that we can say that is definition of perpendicular. Now we have point in the interior. So W is a point in the interior of this angle. And this is very similar when we were up here before. Just said that there's a point between. It doesn't give us anything about the distance. But if it does say, in this case, that there is a point that is on the interior, then we can use the angle addition postulate. So I'm going to write an angle for this one because it's going to be kind of long. So we could say of angle FMW plus, so that was this angle, the measure of WMH, so that's this angle. If we add those two angles together, that gives us the full angle. That gives us the measure of angle FMH. I wrote it on an angle because it's kind of a lot there. And the reason that we can say that is angle addition postulate. which is very similar to segment addition postulate. And again, we have, this is a bisector. And so when we know that there's a bisector, what we want to do is we want to mark our drawing. So if I put 2 marks there, then I got to put 2 marks there. And if I know it's a bisector, then I know that these two angles are congruent. So I can say angle RSW is congruent to angle WST. And that would be definition of angle bisector. The next example we have angle 1 is congruent to angle 2, and I want to make that mark on my drawing. So if I put this in, I put 4 marks here, then I want to put 4 marks here. And if it says that, then what we can say is, if we know that the angles are congruent, then we can say the measure of angle 1 is equal to the measure of angle 2. And that is definition of congruent angles. Got a couple more. Here it says, what do you see? And we have angle 1 and angle 2 shown on the drawing, and those make up a straight line. And so what we can say in this case is angle 1 and angle 2 are supplementary. And the reason that we know that they're supplementary is because they form a line here, and that would be linear pair theorem. Next, we have angle 1 and angle 2, and those are formed by intersecting lines. And remember, vertical angles. So what I'm going to do is I'm going to make this mark here because these are vertical angles. And if I know they're vertical angles, then I can say angle 1 is congruent to angle 2, and that is vertical angle theorem. Again, here we have 2 angles, and we have the box in the corner that shows perpendicular. So in this case, what we can say is angle 1 and angle 2 are complementary. And the reason that we can say that is because of complement theorem. We have 2 at the bottom, and it says angle 1 and angle 2 are supplementary. So if we know that they're supplementary, the definition of supplementary is they add to 180 degrees. And so we want to say the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. And that is definition of supplementary. The next one, we have angle 1 and angle 2 are complementary, and that's the same thing, similar thing, where the measure of angle 1 plus the measure of angle 2 are now equal to 90 degrees. So complementary and supplementary. And that is definition of complementary.